Today we are continuing our division of polynomial by monomial. We are going to go through algebraic method today. Still, what we're going to see is constant as a denominator. And we're going to focus on page 19 of your booklet and page 20. And it's going to be, like as usual, one outcome at a day. One thing that I'm going to do is I'm going to go through two of the example on page 19. First using as tile and then second without using tile so that we can do some comparison. One thing I like to, I got to modify this a little bit. It seems like, can we make instead of 6, 4? And I want you to divide the space on page 19 as left half and right half. Left half I'm going to use with tiles. Right half we're going to use no tile. Something like that. First of all, using tile was this denominator 4 can be determined by either the row or column. I'm going to use row. So vertical setup. 4. And this numerator 4x plus 8 was the one that occupied inside of the table. Like that. As you may notice, everything is positive. So try to have the positive from the positive, then vertical horizontal row should be the one that also give you positive. So long story short, our final expression provides you positive x plus 2. Fortunately, the first example is short enough a question where you can use your tile, but again, if you want to go through a little bit easier method, without tile method is something that you have to have it in your mind. The method is very similar to distributed property, except 4x plus 8 is a fancy way of saying 4x plus 8 divided by 4. So imagine you're doing division for each of the member. Except you don't want to write down like grade 7, 8, bad math, linear method. You can still go through your fraction way of setting as long as you remember that each of the members of the polynomial, it can be binomial or others, you can still divide them. So instead of 4x, actually I'm going to rewrite the whole thing. It's a little messy. I want you to separate these polynomial into half. What I mean by that is 4x plus 4 is actually separation of 4x by 8, but denominators are shared. So instead of the whole thing together, I want you to separate them. 4x over 4 and 8 over 4, something like that. Then we can do the simplification. 4 divided by 4, they cancel out to be 1. 8 divided by 4, 8 and 4 can be divided by 4 for each. So the bottom number is 1, top number is 2. So it becomes 2 over 1, which is fancy way of saying x plus 2. And obviously today's focus is without the tile. Let's do one more. Last time we didn't focus much about when you have trinomial instead of binomial. But don't get panicked. We're going to go through a similar type of a pattern. So first thing first. One, 2, 3, and 4 of the color. and you're trying to have, sorry about that folks, I just mixed it up. In grade 9, come to think of it, you don't learn trinomial divided by constant using the tile. Sorry about that. But we can straightly go to without the tile method. Again, I apologize for the confusion. But in any case, it's very similar as what we did before. You are distributing that denominator for every single one of them. So it should be look like this. First of all, 4x squared minus 12x plus 16, those are together as polynomial. And we're going to divide into each of them. Negative 4x squared over negative 4, adding with negative 12x over negative 4, adding with 16 over negative 4. As you may notice, I included the negative sign for every single bracket. So that means this subtraction by 12 is no longer subtraction, it's adding with negative. And unfortunately, not the same thing, but you don't have to make double negative as long as you're adding with positive. So just for the heads up. Negative 4 divided by negative 4 cancel each other, so that's x squared. Negative 12 divided by negative 4, that's positive 3. And 16 divided by negative 4, that gives you negative 4. So as you may notice, the answer turned out to be x squared plus 3x minus 4. Let's do more examples. Let's do page 20, question A. As you may notice, my first step, step 1, is try to find out the distribution of binomial or trinomial for each of the terms. And it doesn't have to be like term. Most of the time it's unlike terms because they have different degree. Some has x squared, x, or no variable which is constant. In this case, 16v over 8 bracket plus 24 over 8 bracket close. That's my 2 of an expression. 16 and 8 can be simplified by divided by 8 for both sides. 8 and 24, same thing. So my simplified answer become 2v plus 3. There you go. Next example. There you go. 25k squared minus 15k over 5. Got to deal with 25k squared with 5. Negative 15k with 5 later. So bracket open. 25k squared divided by 5. Adding with negative 15k over 5. And I can simplify by divided by 5 for both top and the bottom for the first term. Second term, do the same thing. Then you have 5k squared plus negative 3k. Whenever there's a disagreement of the sign happen, plus a negative or minus a plus, just put subtraction, make it into one sign. Like that. Let's pick up some pace. Today's lesson is not a long lesson anyway. 20 and negative 4. Negative 8n with negative 4. The number that I can divide both top and the bottom is, well, divide both top and the bottom by 4. Then top number become 5. Bottom number become 1. Divided by 4 on both sides, then it's become 2 and 1. So this becomes slightly tricky. 5 over negative 1 is actually negative 5. Adding with negative 2 over negative 1 is positive. So you can rewrite this as negative 5 plus 2n. Or, as you may notice, this is not descending order. So I like to actually switch it into 2n minus 5. This is a little better. We are almost at the end. The first one, highest order, 18a squared divided by 6, adding with negative 6a divided by 6, adding with 12 divided by 6. Any simplification? Yes, we can. 18 and 6 is divisible by 6 by itself. Same thing for the second term. Similarly, the third term. So, 3a squared minus a plus 2 is basically what I have. We don't need to rearrange the whole thing. It's already rearranged. Last step. 7 over minus 7 is my first term. Adding with negative 7y over negative 7. Adding with, is that 14? Yes, 14y squared divided by negative 7. That is what we have. Everything can be divided by 7. Same here. Same to the last one. 1 over minus 1 is just minus 1. Adding with negative 1 over negative 1, that's just positive y. Adding with positive 2 over negative 1 is negative 2y squared. So rearrange everything to the descending order. So technically that means this guy is first, that's second, constant the last. Negative 2y squared plus y minus 1 is thus my answer. That is today's lesson, folks.